Okay, so let's add some behaviors to this scene. So for this prototype, I know I want three things to happen. I want to be able to move the ball's position along this plane. I want to be able to do that with my keyboard or with the left stick of my controller. I want to make it so that the camera is following the ball. And I also want to make it so that I create a goal that I'm able to use as a way of sort of triggering an event. So we're going to have all three of those things happen. Let's do a little bit of housekeeping again and just keep things organized down in our assets folder by creating a new folder called scripts. And then by entering into this, we'll start out and we'll go ahead and create three brand new C# scripts, which will then will apply to different things here in our scene. So let's start out first with a C# script to handle our player movement. And let's just call this one player movement. And so we'll go up to ball and we'll just add this component by starting to type in player movement, and then we'll add it this way. Now, I intend to move this ball using physics, so forces on a game's rigid body. So I need to add one additional component to this. And so that component is a rigid body. And because we're familiar with the 2D workflow with Unity already, we know that if we want to create collisions or some sort of interaction between game objects in the space that use physics, we would normally use a rigid body 2D. With 3D space, we want to make sure that we're using rigid bodies. It's important to also note that these two are not compatible, so we cannot create an interaction between a rigid body and a rigid body 2D. We have to choose one system and then stick with it. We're able to apply different properties to the physics of these game objects to change the way they interact with one another or the way they interact in space. We can also constrain this so that we freeze particular axes or limit the rotation as well, just like we were able to with our 2D game objects. So let's go back here to ball. We're going to go to our player movement script and open it up in our programming editor by double-clicking on it. I'm using Visual Studio, so your programming environment may look a little bit different, but the code will still be the same. Now, we want to create a couple of variables for us to begin working with player movement that will allow us to apply forces to the rigid body based on the input that we're giving, and then multiplying that by a speed so that we're able to set out in the inspector something that we can easily control and tease out until we find like just the right value to make the movement exactly how we want. So up here in our global variables area, we're going to add a variable that first is going to allow us to reference the rigid body component that's connected to this game object. We're only using this within this script, so we're going to refer to this as a private variable. And this is going to be a rigid body. You're going to have to fight the tendency to want to call this rigid body 2D, which I know if you've worked a lot in 2D like we all have, then that's just sort of a natural tendency. We want rigid body in this case, and we're going to refer to this variable within our script as RB. We're going to populate this variable down here in start by saying RB equals, and then we're going to get the component connected to this by using get component rigid body, and then saving that into that reference into RB. Now we're moving our game object by applying forces to that rigid body, and so we're going to not use update to do this. We're going to use fixed update, which is always a great idea if we're working with physics in the scene. It will allow us to work independent of the frame rate of our computer so we get a more consistent result. We could also split up our logic here so that we're handling the directional input in a way through updates so that we get up-to-date information in each keyframe that we're moving forward as our game progresses, and then only applying changes to the physics, to the rigid body in these fixed updates. But in this case, because the example is so simple, we're just going to do it all here within fixed update. Now, we need to be able to refer to the movement or the direction that we're pressing in on our game controller. So we're going to save that here inside of our fixed update in a variable that's going to be refreshed every time fixed update is running in a vector3. A vector3 is going to store the x, y, and z coordinates for us, so it's helpful for us when we're working with a rigid body because it expects us to be able to be dealing with all three of those coordinates. And so vector3 here, we're going to just call this one direction, and we're going to say that's a new vector3. And vector3 expects x, y, and z from us. X is going to handle our horizontal, so we'll use input.getAxis, and then we'll call the horizontal. And I'm using the old Unity input system. As the semester continues, we'll transition to the new one, or possibly use Rewire to handle our game input for us. But in this case, I assume we're most familiar with this method, so we're going to proceed from here. Now, we're not interested in changing the Y position, so the vertical position of our object in three-dimensional space. So we're just going to set this direction to 0 here, and then we're going to fill in the Z, which is going to be our forward motion. Now we want this to be controlled by the vertical axis of our controller, but we're going to use this to either push the game object either forward or backwards. And so this will be input.getAxis. And we're going to say this is vertical. Now, these ranges are going to be from -1 to 1 at most. And so what it's going to do for us is create very slow movement. But we'll go ahead and see how that affects the game object as we move it through space. So we're going to take our rigid body then, and we're going to add that force, so that vector3 that we created, which dictates the direction, just like this. Okay, now we're going to save it. We'll go back to Unity. Doesn't look like we have any errors here, which is great. And let's go ahead and hit play and see what happens. Okay. So now I'm moving it around. You can see the ball moving and rolling here. Great. But again, you can see how slow it is. Now, again, depending on the kind of game we're making, the slow movement might be ideal. We can make changes to this by changing the mass or the drag on our rigid body here. But it's probably a good idea for us to give something to multiply this this limited directional value that we're creating here and storing into direction, and multiplying it by something. So let's create a public variable, and we'll make this a float, and we'll call it speed. Now, we're making this public because we want to have this something that we can tweak and tune through the inspector and not just simply through our code here. I'm going to go ahead and set this to default value. The reason I tend to do this is because this is something that I often overlook, and then when I go back I can often be very confused as to why there doesn't seem to be any sort of notable change. This ensures that I'm going to get some sort of feedback if it's working, and no feedback if it's not. Now what we want to do with speed is we want to take this and multiply it by these directions that we're getting through the axis of our controller. And so we could add that here, and we could say input.getAxis horizontal times speed, and we could say this one here vertical times speed, but we can actually also do this down below here and add the force, which is just multiplying direction and speed together. Because we're we've chosen to explicitly limit the Y movement to 0, we don't have to worry about like suddenly moving in an unexpected way along the Y-axis, because 0 times whatever that value is going to be 0 as well. So let's go ahead and save this, and then we'll go back to Unity and let's see what happens. Good. All right, much faster. Great.